In this video, we're going to look at a problem where we're going to add two vectors together. So vector A is 300 meters, 35 degrees below the positive x-axis. Vector B is 500 meters at 55 degrees above the positive x-axis. What is A minus B? Now, you're asking yourself, I said this was a vector addition problem, and yet we're subtracting. But keep in mind, when we're doing a subtraction, that it's really can be written as plus and minus. So what we're going to do is take vector A and add the negative of vector B to it. All right, so let's go through our process. The first step in our process is to draw a diagram to help us break those vectors into components. So I'm going to draw some axes here. So positive y, positive x, negative x. All right, so vector B is 35 degrees below the positive x-axis. So that's going to be this angle in here. So this is our vector A. And then vector B is 500 meters at 55 degrees above the positive x-axis. So vector B here is going to sweep above the positive x-axis. All right, so now I need to draw in my right triangles. So we have AX and we have AY. And then we have BX and BY. All right, so when I look at this, I can see that the angle provided is adjacent for X and opposite for Y, and for vector V, X is adjacent, Y is opposite. So that means I can use cosine for my X values because they're adjacent to the angle provided, and sine for my Y values because they are opposite to the angle provided. All right, so we're going to do AX equals A cosine of theta, and AY equals A sine of theta. So we're going to take our 300 meters times the cosine of 35 degrees. Make sure I get my extra 0 in there. And my 300 meters times the sine of 35 degrees. All right, so I'll fill that in a second. Let's look at B. So once again, we're going to do B times the cosine of theta. So we're going to do the 500 meters times the cosine of 55 degrees. And then for the Y, we're going to use sine again. So 500 meters times the sine of 55 degrees. So now let me get my calculator out and figure what those values are. Now that we know what the components are for each of the vectors, we have to decide whether they're negative or positive. So let's start with vector A. Vector A goes to the right, so positive x, and then down, so negative y. So in here, I need to add a positive sign here, which really doesn't change anything, and then a minus sign there. All right, so for vector B, we're going to the right, so positive x, and then up, so positive y. So that means that both of these are going to be positive, but we're doing the negative of vector B, which means I need to flip the signs of my components so that I'm subtracting it and not adding it. So that actually means that we're going to use a minus sign there, and we're going to use a minus sign here. So both of those components are actually going to be negative to reflect the fact that we have the negative of B. All right, now that we've established the sign for our components, we can add our components together. So Rx is going to equal AX plus BX. So we're going to take 246 meters plus a negative 287 meters. And then Ry is going to equal AY plus BY. So that's going to be a negative 172 meters plus a negative 410 meters. All right, so let me pause and get out my calculator. All right, so we get that Rx is a negative 41 meters and that Ry is negative 582 meters. Now we want to make use of Pythagorean's theorem. So we're going to take a negative 41 meters and square it under the radical plus the negative 582 meters. And be careful when you're putting this in the calculator. You do need to put your number in parentheses before squaring, or else your calculator probably will not square the minus sign and you may get an unreal result. Alright, so we get 583 meters as the magnitude. Now we need direction, because remember vectors always need magnitude and direction. Alright, so in order to do this, I'm going to draw a new coordinate system here. So positive y, positive x, negative x. And both my components are negative, so I'm going to draw my x component always first. So I'm going to do a negative x and then a negative y. So that means my angle I'm going to end up with is below the negative x-axis. So I'm going to say theta equals the inverse tangent of ry over rx. So Ry was negative 582 meters, and then Rx was negative 41 meters. All right, so I'm going to take the inverse tangent of that relationship. That gives us an angle of 86 degrees, which is going to be below the negative x-axis.